for coming today, and it's my honor to be here to come back to the university and give something back 10 years later. We're going to talk about BIM, and the focus isn't going to be on BIM as a piece of software. BIM is not software, BIM is a way of thinking and a mode of delivery, and that's what we're going to talk about today. When I use the term BIM, I use it as a verb, so it's building information modeling, but the action is building. So it's BIM the verb as opposed to BIM the noun. The noun would be the model, the verb would be making the model. So you can BIM anything, and it's essentially the characteristics of what it is, why it's there, and the information about it. So BIM is multidiscipline, and in this presentation, I'm going to be alluding to facilities. So when I say multidiscipline BIM, we're thinking of buildings here where you've got, in this image, you're seeing architectural components in the same space as the structural components, same space as HVAC, lighting, furniture. Notice they're all sitting on the site. All of those components form a combined whole. The whole concept of BIM is that we're all working live in a virtual environment, developing a model as it would be constructed in site prior to ever digging the first shovel into the ground. BIM is geometry plus information. And for me, this is the fundamental, because when we talk about BIM and we deploy BIM, and architects or engineers will say, well, I run a small practice, BIM is expensive, BIM is new, I need training, I need software, I need hardware, I need all these wonderful things. I always ask them first, well, do you even know what BIM is? Other than you need software and hardware and training and all the expensive things. This is the fundamental thing. So if you look at this room, you got walls and ceilings and floors, acoustic panels, projectors, chairs, finishes on the floor. You've got all this wonderful stuff. So imagine designing this space. The model knows what all of these things are. And that's a huge fundamental difference from if I was doing a project outside of BIM. So when the example, that data down the right there, that is an air condensing unit. So the reason I choose that is because you can have extensive data and you can have simple data. And what people always get caught up with is, oh, BIM, the unbearable, unthinkable, I can't really do this because it's so mammoth, I don't know all that information. But if I'm modeling this room, I would hope I know walls, floors, and ceiling, right? It's kind of simple. So the concept is, do I just draw a line, an unintelligent line? Do I draw an unintelligent 3D form? Well, the good thing is this is where the software comes in. Regardless of what BIM application you use, it won't let you do that. So if you want to just draw a wall, every single BIM software says place wall. It doesn't say draw unintelligent 3D form that has no data. There's no command for that. So that's a beautiful thing. It actually makes you sit down and think, am I going to press the slab tool to draw a wall? Am I going to press the ceiling tool to draw the floor? Am I going to use the roof tool to draw a chair? If you do that, you're going to have one wacky BIM model, right? But it's so intuitively, the tools really push and enforce the use of BIM. So you think, what's simple data? The simplest form is, I model this room, I know the walls, the ceiling, the floor, and the furniture. Simple, right? I can then take that model and do so much with it from simple fundamental data. And I'll talk a little more after, but then we further that information. So internally, we have cost estimators who say, it's not enough to tell me it's a wall, I need to know CMU versus acoustic panel. I need to know concrete floor versus finish. And they start adding in more and more particulars that help us to drive what that data means. When we have components like that air condensing unit, they want to know the voltage. They want to know where it is, what goes into it, what comes out of it, so then all of the technologies and disciplines can talk to each other across the board. This is a project I worked on 10 years ago now, so it's been a while. I show this because that's my drawing, and that just sucks. There is nothing special about that drawing, other than the fact that I have to produce that, I have to put my stamp on that, because that's the form of contract. This is what it's all about. That drawing is a simple cut from this model. This model is the single source of truth. If you go to a BIM presentation and you hear somebody saying, BIM is a paradigm shift, I've heard that I can't tell you how many times. What's the real shift? Things happen here, not in the drawing. That's all. I want to make it sound so simple because it is. And when you think about BIM, think about how you think. When we're all designing, whether it's structural components, civil components, mechanical, electrical, architectural, we're thinking of the component itself. I'm not imagining to draw this thing here. How does it look in plan? How does it look in section out here? How does it look right here in the physical space? That's the first thing I'm going to design. That's what the model facilitates. Drawings, simple output, press a couple of buttons, I get a drawing. And then all the other information comes as a byproduct. The other thing we push, and this is more of a behavioral, is let's try to make decisions and stick to decisions. I am an architect, and I will be the first to make fun of architects. There are so many architects out there that want to design, and change, and think, and reiterate, and go back to the engineers and change things. Often then we can, engineers are the same. I've seen beams that are like this, then they're like this, then they're like this, then they're like that. Why are the beams doing all these crazy things? And we have this back and forth dynamic, and my argument will be, let's do that when we need to do it. So if you're familiar with four-phase design, and that's really started with the American Institute of Architects. CH2M Hill, we deploy that wholeheartedly. So conceptual design, schematic design, design development, contract documents, and then you're into construction. We'll say the ease of design changes is the easiest in concept. If the beam has to change 10 times, if my walls have to move, shrink, twist, turn, if I decide instead of straight I want to do some curvy, frank, everything, why not, right? Let's do it all there, not in construction. Once you guys pour the concrete wall, I'm not going to come and twist and turn the concrete wall, right? It just can't happen. And that goes back to cost, right? So it's easier and cheaper to do it earlier in the design. So we say, stop making decisions at the end, push your decision making earlier, we're all in one happy family, end of story, right? Very difficult. It's behavioral. It's nothing to do with BIM, nothing to do with software, everything to do with the people, the architects and the engineers and the senior reviewers and management, able to sit down and say, this is what we want. And even the clients and the owners, for them to understand early on, yes, I want my design, I want my building, my space, my site, my whatever, to actually be that way and not make changes at the end. We all work in isolated silos. And hopefully one day we talk to each other throughout the course of design. We make these contract documents at the end of the day, and one day I hope we talk to each other, right? That's the pessimistic way. We've been building things for 2,000 years plus, but still, it's a real bad way to work. Why do I have to design and guess what's going to be there, right? When I can use BIM, and I can see everything. We're all together in one virtual whole. That construction set is one little piece of the puzzle, but again, an output. Those drawings, plans, sections, elevations are nothing, and I'm going to keep stressing that. So BIM, the fundamental is the model. Somebody asked me once, can you have BIM without a model? And I do have an example of that, so the answer is sort of yes, but pretty much no. You need a model that contains information. And the one example we have are space charrettes, where we sit down with clients, and we'll talk about that, but it's really 3D conceptually. So the fundamental is the model, you do all your work in the model, everything else around this wheel of BIM is completely a byproduct of the model. It's a detriment, specifically with drawings, and I've seen this, and I'm going to pick on a structural engineer, dear friend of mine. He would come over at the end of the project and say, erase that number. Instead of the beam being 300, we're going to make that 350. Just write it in. The world was simpler in 2D because I could just erase a dimension and change it. So when we started modeling heavy, we made it like a complete standard maybe 10 years ago. The first feedback was, well, all of a sudden it's more difficult. This does not work, Brent. We cannot do this. We cannot deliver projects on time, on budget, this and that. And the question was, why? Well, I can't erase that number anymore. I asked my tech, my drafter, to erase the number, and he said, no, I can't, because if I make that beam bigger, it has a ramification on all the other systems. So management and everybody looked at this engineer and said, well, duh, it always happens, right? So the thing is that BIM is exposing all of the issues in design before they get on site. The beam comes in, all of a sudden nothing works. So from the model, the fundamental, we can analyze. Now this is huge. We never could analyze 2D CAD drawings. There's no such thing, right? If you model correctly, and again, this comes back to wall, just this room, wall, ceiling, floor, door, window. That's all I need. I can model this room literally in seconds and then bring it into an energy analysis tool. And the energy analysis tool should tell me that I'm going to lose some energy through those windows. But if I call the windows another type of wall, it won't tell me anything. If I call the ceiling a slab, it won't know I have a ceiling and it'll think that I have an unenclosed space and there is no energy anywhere. It just, I'm open to the world, right? So fundamental things like that. Use the tools, use them intelligently, and all of a sudden we have the ability to analyze. Structural analysis is fun as well. You got beams. Well, if you don't call it a beam, you pull it into a tool like SCAD or RAM, It's not going to know it's a beam. It's not going to know your column is a column. So we have that interesting where, let's pretend there's columns behind those panels there. Well, if somebody modeled them as walls, you pull it in, you're just going to think your building's going to fall because there's nothing holding up your beams, right? So it's little things like that where all of a sudden the doors to analysis of, the doors to the analytical possibilities are completely wide open. Visualization, push a button, you see the model, right? So you come up to as early as 30%. I can take a model, literally hit print screen, send it off to my client, and they can see how the building looks, how the space looks, a structural section, how it looks on site. They can see access roadways, they can see everything because it's right there sitting in the model. Specs are pretty state-of-the-art now, which is sweet. So if I model this space, most BIM tools today will be able to understand that if I have concrete masonry unit, that's a Division 4 spec. If I have metal panel, wall paneling, that's most likely Division 9. Flooring is Division 9. Windows are Division 8. The models know that. So they can now analyze the models and get a list of the specs used. So they'll see there's a door division on section 8001, there's a window section 8010. There's, I can't remember, 4200 for the CMU. It knows all of the spec numbers that get carried on the components. Now I can harvest what specs are required for my project and pull them from the master system. So with a couple pushes of a button, I'm now at 60% and I've already harvested my project specifications and have the system do a first cut edit of them. Fascinating. We're actually building that in our systems now. It's pretty new with the current tools, but it's going to make life quite. Design review, we sit the client in a room and say, do you like what we're doing? And the client has a look. The client doesn't have to go through tons and tons of drawings to understand what we're talking about, right? We drive them through, we give them the mouse, we say, hey, why don't you drive? And the client's all nervous and they try to drive and they think it's like the sweetest thing. And we're like superseding to a hill because we gave them a model that they can do a first-person drive-through and yeah, we're great, right? Byproduct, it just doesn't matter, it's just there. Clash detection right in front of the client, or most likely not, or more so right in front of our management. We press a button, we see a list of what's touching what. So you have a beam going through a window, you have a duct going through a beam, you have I don't know, this thing put in front of a door. All of that can be automated and clash detected, and we can see and cycle through, see what a clash is, mitigate it between our discipline leads, our engineers and architects, and come to a solution. Always in design, never in construction. Cost estimation for us is a big one. And this came heavily on our design build work, where we basically were losing money because we would go in thinking we have 10,000 cubic meters of concrete, we found out we had 15,000. Some cost estimator missed the number, missed the drawing, missed whatever, and we just completely messed up our bottom line. So we press a button, we get volume of concrete. Now this has taken years and years of refinement. So BIM out of the box, I press a button, it'll tell me volume of walls is X. Sure, that's good. Cost estimators say cast in place concrete walls are less expensive than walls underground with hydrostatic pressure or just pressure from dirt. Cast in place concrete slabs on grade are less expensive than cast in place concrete elevated slabs. Elevator pit slabs have a different cost associated to it, and it's mostly because of rebar or forming or etc. So what we've had to do is build the definition so that when we press the button it says total volume of slabs is X and total volume of elevated on-grade and pit slabs, we give them a breakdown as well. So when our modelers model, they understand or they ask the question, hey, what am I actually modeling? Is my wall above grade or below grade? Is there hydrostatic pressure? Where's the water table? What's the influence on my concrete wall? So when we hit that volume button, all of a sudden there's something that can be immediately estimated. Same goes with ductwork and piping. So we press a button, it'll tell you length of pipe is X. Well, that's kind of meaningless for estimating, right? We need to know length of stainless steel pipe, length of cast iron pipe, length of FRP, length of PVC. Once we know that, then we say, well, is there anything special with what's running inside these pipes? So we do a lot of water treatment plants. So high pressure piping is more expensive than low pressure piping. So we go through all of those analyses, filling out data as we put content into the models. But the models help us. So when I hit place pipe, we've written our tools to say, you can't place the pipe unless you tell me what's the material, what's in it, what's the diameter, what's the pressure. We force those questions. If I'm modeling the pipe and I don't know the answer, my philosophy is stop modeling. Get out of that tool, go for a walk and ask your designers and engineers, what do we do? we're doing it. And finally, scheduling. I have an example I'll show later on, showing just essentially you can bring in a timeline, you have a bunch of components. In theory, the building's going to grow from the bottom up, right? So we can schedule that. If it's modeled correctly, we can make it grow from the bottom up. And then we can push the data beyond into post-design effort. So design review can become constructability review. Quite simply, it's the same concept. But we now have fabrication and procurement. And those are huge items, especially on design-build projects. So for us, when we do these water treatment plants, I can procure valves, I can procure piping, I can send my steel to a fabricator, if it makes sense for the project that I'm working on. And it's all based on intense and robust data. I can't give my model to a steel fabricator and say, hi, here's all my beams. And the fabricator looks at the beam, there's no beam marking, there's no dimensions, there's no weight, there's no anything. What's he going to fabricate, right? All right, let's start from the beginning. So what's level one? This one here is really more geared towards the architect who has never BIMmed anything, but we've used similar concepts for site planning as well, so from a civil side. And it's really from a shredding standpoint where we say, well, sit down with your client and owner and start laying things around. Where are the buildings, where are the open spaces, or what are your rooms within the buildings? And just start laying out these little blocks. But instead of using the rectangle command, use the space command. All of a sudden it's intelligent. It has spatial dimensions, so you get areas, you give it a height, you get your volumes, and from those spaces you can now generate walls. Whether it's interior walls or exterior walls, just by press of a button, flood the space, get your walls. Immediate. And I make it sound so simple because it is, and I've tried it in various tools. If you just use the rectangle command, well, you have no intelligence. Why would you even do that? And I say it this way because I've had to fight the fight for years, especially when I started at CH2ML, with BIM is expensive. And always, why is BIM expensive? Because you're using it wrong. You have to understand what you want to do with the BIM and take those initial steps. You then start the BIM buildings, or BIM entire spaces, or BIM entire sites. They can be limited to one discipline or multiple. So this example here, this level 3, architectural and structural, we're doing BIM, MEP we're not. It just couldn't happen. And I believe civil was as well in this example. Then you have super BIM. You just BIM every single possible component. This here, this level 4, was done for the Department of Energy in the state of Tennessee. And they said to us, can you BIM us telephone jacks? So we sat down and we said, well, we didn't know, right? So we sat down and said, well, what's a telephone jack? It's a rectangle that's about that thick. Okay, so it's pretty easy to model. You model a little rectangle copied all around the place. What's unique about that, you've got to know it's a telephone jack. So we wrote a little data piece to say telephone jack. And they wanted a number. They wanted a number to match their asset management system. So we gave them all numbers. All of a sudden we BIMmed telephone jacks, and we were able to give them a listing. That's the wheel of BIM I just talked about. I built this slide for the London Olympics. And there we were looking at, well, what do you do with the data, right? So when you think of modes of work, you can have a consultation, so design bid. I do the design, we send it out to bid, it gets tendered. I, the architect, or I, the engineer, am not involved in construction. I'm just kind of being engaged. The building code says we have a general awareness of what's going on during construction. And at the end of the day, we can generally say that it met our intent. So that's very ambiguous, and we're really not responsible. On a design build, we're the contractor. So all of a sudden, we spent maybe a year building these design models, and now we are this contractor, we have all this information. Well, what do we do with it, right? So when I said drawings are an output, this comes heavily in play with work packaging for design build projects. I the contractor, will call my precast up, and I'll give him the information he or she needs. I don't have to give them, well, this is all the drawing shows, please interpret it. I've got models, I know what all the components are. I can isolate all the components. I can give them just what they need in a specific work package. I can plan my phasing, I can do my schedule simulations, I know how things are going to come into and out of my sites. Most importantly, I get an as-built BIM model. So as I'm building things, if, for example, a valve is specified, you have a sewer system with a relief valve or something, in the middle of the floor, I have three options to specify, I pick one. all of a sudden that drives specific geometry, specific inputs and outputs from that valve. All that's going to be buried in some concrete floor or some roadway, never to be seen again, but it might need maintenance, it might need attention, people need to know it's there. I have all the information input from what I procured and installed in my model, turn it over to my client for operations and maintenance. On a real expensive project where we're designers, builders, and operators, well, this is super. So I was working on a treatment plant complex in San Diego. 06 we did the design. It went to construction 08. It finished 2012, or late 2011, I mean. And we're going to be operating it to 2025. So that same model I worked on in 06 is going to be receiving information straight through 2025. And the idea there is, like, what would you put in a model? So, you know, there it's a lot of treatment information, but my favorite example is the Panama Canal. The gist of that program is the ships can't pass through the canal, right? Pardon?
Why?
Oh, because the ships are too big. The canal's too small. Right, so you can go into the canal system and you've got locks, which basically raise you from the Pacific Ocean to a mid-lake, from the mid-lake to the Atlantic, right? The locks, I think, were finished construction in the 20s or 30s or something. So I think ships that were built post-70s, they don't fit anymore. So they said they've been diverted around South America, and there was always an intention to make the locks better. So we're involved as program managers, joint with the client, to build a new set of locks beside all the existing ones. The new set will let the big ships go through. What they want to understand is there's external entity who's doing a model in Revit, and we've made sure that everything they have in that model can be categorized and cataloged. So each and every single component has a unique identifier. We can now take that into a facility management system, and using, for example, the concrete lock walls. They have a 100-year lifespan. So if I take this mammoth concrete wall into the facility management system, I can make a note saying, okay, construction's done 2014, come 2114, somebody better start looking at these walls and make sure that none of them are failing. But let's say in 2020, there's a crack, right? Something's happening to the wall, and we want to go and repair it. So as facility managers, they will go and repair the wall. Well, that repair is not going to have a 100-year lifespan. It's only going to maybe have a 5-year lifespan, maybe a 10-year lifespan. So now a 100-year wall that needs to be attended to in 2114 will have a component on it that needs to be attended to in 2025. So it's that type of mentality. And you think, well, we're BIMing a crack repair. But that's exactly what it would be. So it's a 100-year item with components that will need to be addressed throughout the life cycle of its existence. On the London Olympics, we completed the games management as part of program managers with the authority. So the games are done. Now there's all these venues left. So, you know, you think design, build, operate. Well, what happens after that, right? Things die, right? Things move on. London Olympics is a great example. It was design, construct, operate. Operate is done, the Olympics are over. We have these venues now, and the Olympic Stadium is my favorite example. 85,000 seat stadium in Stratford in London now has to be decommissioned down to a 35,000 seat stadium. And that stadium, we designed the decommission, external entities designed the decommission and laid that out with a BIM model probably back in 2008. So as an authority and a program manager, we knew what was being taken off of that stadium come post-Olympic Games. We knew what had to be recycled to meet our recycling obligations, and we were able to demonstrate what would be there for development purposes, resale, and everything. Okay, step back now. How do we do BIM, right? What do we do from a modeling management standpoint? I want to touch on this because it comes down to not only model management, but data management and connectivity. And for me, it's a powerful thing to understand, you know, you've got all of this information. Where does it go and what do you do with it? So some tools work upon a centralized model. So a centralized database where entities author content and move content back and forth. So here, there's a central model where I'm going to pull information from and push information back. We're all pulling and pushing, and that's the name of the game. So you can imagine benefits of that, and it works really well when we're all combined in one office, right? We had struggles where they would say, well, we prefer all accessing the database, yet when we try to distribute across a global network, all of a sudden there's different access speeds and different abilities to actually connect to that information. So that project manager down there, if you can imagine them being in India, which was the case for us, well, the BIM doesn't work, Brent, this is just a failure. Why? Because it takes me hours and hours and hours to open up a file. Fair enough, I can't argue that. So in CH2M one of our preferred approaches is a federated database where it's like a puzzle that we distribute across a network. Now CH2M we're able to say, I can work on a project from anywhere in the world, whether I'm inside or outside of my network, it just doesn't matter. I can get all of you to collaborate on my projects based on this federated model approach. We're all authoring something. I'm the architect, I author my content. If you're the structural engineer, I will never touch your content, you will never touch my content, same with everybody else around the key. I can't go to the civil engineer and start manipulating and moving the site. I have to talk to them about what they're authoring and accountable for. One of us updates, where it's like just throwing puzzle pieces back and forth, and updates occur periodically as we're authoring our own content. Now, again, even though it's federated, it's still glued together using a tool that I'm about to talk about, which facilitates the design collaboration. This works fine for us in one office or in any combination of offices, it just doesn't matter. So when people ask, well, what tool should I use? How do I start this? How do I set this up? I ask them to think about, well, what is your approach, right? You're going to use this federated, spanning multiple offices. You're going to use it centralized. Is there multiple offices? Understand what you're doing. More critical, and what we're finding, especially in the realm of program management, is do you have external entities? So am I going to be hosting a BIM model and asking everybody outside of CH2M to come and collaborate with us? That makes an intriguing situation. Issues of connectivity, issues of security, issues of just getting us able to collaborate and having consistency in all of our BIM data. But if I'm going to ramp up a team, the first thing I'll ask them to do is understand that we're doing BIM. And I know it sounds kind of silly, but that's almost been one of the hardest things, right? We're not doing that. That doesn't mean anything. That's an output. We're doing that. Single source of truth. So critical, and I'm not going to harp on that anymore, but that has to be understood. Pick the team. Are we using centralized, federated, internal, external, multiple office, one office? How is it? As we grow in BIM, we discover, well, BIM is forcing us to do things, and we try to automate those things, so it's not a big deal anymore. So when I say a project manager will come to me and say, so Brent, 50 years ago, 20 years ago, architects took 40 hours of drawing to draw. And then we got CAD, and it took 40 hours of drawing to CAD it up. Do you still need 40 hours of drawing? I said, well, if you're going to give me that, fine, but I don't need 40 hours of drawing. I can do what I used to do in 40 and 30 or 20. And I've demonstrated that. And it's because of BIM. So now when they give me 40 hours of drawing, I give them drawings and renderings and videos and all these wonderful things because I have a model, right? And they believe me now. Before they thought I was full of it 10 years ago, now it's impossible. So once you start doing BIM, right, you're going to connect. You're going to create content. Your content's going to be intelligent. I'm not going to model that door from scratch every single time. I'm going to model it once, give it the right data. If I schedule it, I know I can get the schedules I need for my architectural content. I know that if, let's say, if there's an electrical component on it, card readers, electrical strikes, whatever, I have the BIM data inputs that I need that I can send the information to the electrical engineer, and I have this intelligent control component that I'm going to manage and preserve. Preservation is critical. How does BIM become more efficient, right? I build all of this stuff that I'm going to model, and I keep reusing it and building more and more and more. Your library becomes massive. Software vendors help us as well. As we build content, we all collaborate. So all of our competitors, we actually play kind of nice with this, because what we build, we give to the vendors. What they build, they give the next version of the software. Wow, there's all this cool new stuff in the software. It's us helping. Now, Autodesk has Autodesk 360, and they offer their own cloud solution. Bentley has a cloud solution. What we find difficult with third-party hosted cloud software is ensuring security of our data, especially when we have clients who will insist that the data must remain within our networks. So we had to come out and devise a cloud solution for ourselves, internal to our environment, that allow us to distribute. So this is a technical slide from Bentley, but basically I want to describe it as a puppet master with puppets, okay? So the middle is the puppet master. They have what they call an integration and an orchestration server. Basically it says, We're going to have all of these puppets all around the world. I'm going to integrate you all together and pull the strings and orchestrate all the data. I'm going to manage how all that information moves around the world. Then the offices, we have caching. That's all, caching server. The beauty of that is it says, if I'm sitting in Sydney, Australia, working with somebody in Toronto, Canada, I'm not going to be working off of a wide area network trying to read information from Australia to Toronto. It's never going to fly. So we locally cache. ProjectWise orchestrates that and says there's information in Toronto, I'm going to sit it in Australia, I'm going to talk and make sure it's perpetually synchronized. Then the person in Australia works off of their server, the person in Toronto works off of theirs, and that's the same for every single one of our offices, and we have 200 worldwide. And then through the internet, the system says, well, you're not always working with people inside your environment, so let me give you a window into the outside world. This is ProjectWise, looks like Windows Explorer. It's just like, you can think of it Windows Explorer on steroids. It's doing all that stuff in the background. So, maybe I didn't put the slide in here, but there's two things with ProjectWise that empower this. It's a distributed file system, and it uses Delta file transfer. Two things that have made our lives easy and feasible. Distributed file system means you look at that, you see the whole, you have no clue that every single one of those projects and all of the subfolders are locally stored in different servers, cached all over the world, and being orchestrated. You have no clue, it just doesn't matter, it's distributed. Delta file means, if I'm the architect and I reference your civil base file, that might be 100 megabytes. I bring it down the first time, 100 megabytes come to my system, you add another megabyte, ProjectWise says, well, you don't need 101 megabytes, you just need the one change. So it'll send me the one change. You add another kilobyte, it'll just send me the 1 kilobyte. And that's what it does. So I after downloading the first time, never ever ever have to download a resource ever again unless it's updated, and then I only receive updates. CH2M Hill, we said, well, how are we going to do this? We have a corporate data center with fail-safe if it's our Denver office and Denver blows up. We have a bunker backup, so we have all, ProjectWise could be down for no more than 30 minutes. It'll be back up, running, full operational. Each office is a site, so it, as I said, caches and brings it down. We go through our demilitarized zone. We've got a gateway. We can get other offices, other users. I can work from home, in my basement, through my light internet, hit all of my content worldwide, and not feel any pain. Our ProjectWise system, that's our work in progress BIM authoring system, okay? It has a strong interaction with SharePoint and other document management tools. EB Insight, this is a Bentley-based slide here, unfortunately, so it has a tool. But if you've heard of the tool Aconex, if you've heard of Asai, if you've heard of Primavera Contract Manager, there's all these document management tools. So basically it's something at the top, and I don't care what the names are right now, something at the top for BIM authoring work in progress. The one on the bottom right is for program documentation, announcements, calendars, stuff like that. ProjectWise doesn't do announcements well at all. And the bottom left is for contract administration and tracking of transmittals. That's kind of the overall program management question or problem that we need to solve with these tools. And again, change those names with whatever you want. I've gone all around the world, and the first time I heard of Asai was on the Olympics. Somebody said, well, why don't we use Asai? We use that in the UK. I've never heard of this tool in my life, right? But we had to analyze it and see what it could do and compare it to the other tools. And yeah, as long as you're able to do some of the things that are on there, it's all a viable solution. But for ProjectWise, at the top there, Delta file transfer and caching servers. And data compression. Those are three things that ProjectWise, and that's why I keep stressing that, it does that where none of the other tools could do that for us. And it was a critical thing to actually enable us to work share across the globe. Then we want to share resources. Resources, like I don't want to make layers and you make levels and I make a part and you make a part and I call it a door and you call it something else, right? So basically our solution is come to our collaboration system, access it, check out a file. You're going to get locally cached references the first time, and the second time you're going to use Delta file transfer to update. Then we have all of our resources. I'm going to give you all of our CAD standards, all of our BIM standards, all of our everything the first time. That could be a gigabyte of information. Go take a coffee, go have a coffee, go do whatever you want when you download that the first time. Second time, it's just going to synchronize a compressed file. That's all. author your content, check back in. So the way it works is we have these compressed files where thousands and thousands and thousands of files are compressed into one. We give you the one file, project-wise, puts it on the computer, make sure it's current. So the entire BIM data set for Revit or Bentley or Graphisoft or digital project is upwards of the 500 to 600 megabyte mark. We give you that one file, and if it's current, it's great. What it then does is deploys it to your system, and then the configuration lets you see all the content. If I change a piece of that, well, you're going to get the change. Not a big deal. You're never going to get 500 megabytes again. You might get one. Remove the dependency on external resources. So if I'm working with you guys as an external entity, I don't want you to be dependent on saying, well, I can't see CH2 and Hill servers. I don't care, right? You don't need CH2 and Hill servers. We're giving you all the content. As long as you can see your C drive. If you can't see your C drive, we've got issues. But if you can see your C drive, you can work. Once we've done all that, now we talk about, well, how do we leverage cloud computing, right? So, some tools do things better than others on the cloud. Here's an example of just processing and reading interferences. So we're able to take the models from our system and scan them for interferences, leverage the data, see what's hitting what and why, and figure out whether it's a good clash or a bad clash. And when I say a good clash, if it tells me I've got a table sitting on the floor, so what? That's a good clash. I probably want the table to sit on the floor. But if it tells me I have a beam going through a window, that's a bad clash, and it'll identify it for me. So what we've done is they try to take the most restrictive of all the codes. So the example there is IBC says you can have your maximum rise of 7 inch, right, 180. ABC, so Alberta code says that, National code says that, the Ontario code says 200 millimeter, not 180. So when you look at that and you say, well, when I'm doing my design, my BIM tool says 180. If I put my riser as 200, it'll give me a warning saying you're outside of the riser constraint, and you accept it because you're in Ontario. So there's no way the tools can cover everything building code, but they have tried to look specifically for the North American data sets to try to get what's mostly common amongst all of the codes. It was actually, it was a little pump house in a golf course. So the client actually wanted to see elevations, and then they wanted to see, well, can you give us a rendering or whatever? And I just kept pressing the button, and I said, here you go, a rendering of a pump house, but why not, right? And the PM kept saying, well, how are you doing it so quickly? I said, it's because I'm filming it, right? It's just how we do our work. And it's the same. I think about a 5x5 pump house, right? 4 walls, ceiling, roof, and I think I had 2 doors, 2 louvers. What does it take to do that? I would have spent more time drawing plan section and elevations than I did modeling it, for sure. So, from a constructability review, this was a project where the client, this is that Super BIM project, Department of Energy in Tennessee, they said, we don't get this, can this actually be built? So we took the model, and this is just a simple animation, right? But the critical thing here is it was modeled correctly so that we could break the components apart and show them how this thing is going to be built, right? And when the client looked at the left versus the right, which one do you think made sense to them, right? And that's the power of this tool, not only to just say, here's a picture, but I can now animate that picture and actually show them how things are going to be built and brought into place. So you can do photorealistic. Now you can watch as it's rendering. It takes a little bit of time to regenerate graphics because it's actually doing the materiality as well as the components. But this is live in the model, right? So when I'm actually building this thing, whatever tool you're using, you just hit the walk command, start walking through. This is where my senior reviewer will come over and say, hey Brent, can you show me blah, blah, blah. I just sit them down, hit walk, and say, what do you want to see, buddy? And then they say, well, I don't understand that, so I'll cut a section and show them. And you have all these manipulations at your fingertips because you're able to allow them to understand without having to, oh, wait, let me quickly press print and let me go find the drawing. Oh, let me cut a drawing. Such a waste of time. You can tell how much I love drawings, right? This was great. This was a nuclear facility. We required a 4-hour fire rating and a certain PSI blast protection on the nuclear waste storage. The client said the contractor said there is no way that rebar is going to work. So our structural engineer said, well, I'm going to get one of my savvy modelers to model a section of the rebar. So they put this thing together, put it into 3D PDF, that's all it is. And you can interact on a 3D PDF, and we were able to actually show them the configuration of the bars and prove to them that when you pour the concrete, the aggregate will fall between the bulk of these bars, and we should have something that will work. Contractor said, I think I can give it a try. This is, again, a 3D PDF. Any BIM authoring tool can export, I think anyone can export to PDF, and you can energize walking capability. You're just able to drive through the model. Again, it's a PDF, so it's really dumbed down graphics and everything, but just imagine you're working on a model of anything, sites, buildings, whatever you're working on. You hit print to PDF, and you send it to your client and say, here, open this in Adobe Reader and drive. This is simulation. So this one here, this is, let's show how this building, and you can tell we did this 12 years ago, is when we did this model. And this was one of our first BIMs where we wanted to show how it's built. And we actually found a huge gap in how we were working back then. And that helped us to continually stress model as it will be constructed, not any other way. And you can see here the columns going up floor by floor by floor. Well, what the modeler initially did was model the column from base straight up to the top. Thought he was being quick, which was okay. If you cut plans in sections, it would look okay. If I took quantity of steel, it would be okay. If I did visualizations, it would be okay. But the minute we tried to simulate it, all of a sudden we were getting floor-to-ceiling columns, which no way would ever have been constructed that way, because that's a 6-story tall building. So that helped us to learn very heavily that, you know, sometimes the quick way is not the best way, and that's where we prompt this project automation lead role to ask, what are you doing and why? What's your BIM goal? If my BIM goal is schedule simulation, I better be modeling those columns in the pieces as they will be constructed. My BIM goal is drawings and I have a tight schedule and a tight budget. I might be tempted to model 7-story high columns because it'll get me my drawings and it'll look okay. Quantification is pretty big for us. And when you link it to schedule simulation, there's a nice conflict there, right? If I need to quantify that concrete slab, I just need to know that it's a concrete slab. But if I need to simulate that concrete slab, I need to understand how it's going to be poured. And that's a huge difference, right? Imagining the pours on a 500-meter long concrete slab. If we're in design, we may not know. If we're the design build contractor, the contractor might be able to give us advice on that. But we need to understand, if the goal is simulation, I need to account for that. If the goal is quantification, I don't really need to think about that. And then we talked about energy analysis. So, heat recovery, heat gain and loss, sustainability, daylighting, and structural analysis are the most critical ones that we've used internally. Heavy emphasis here on LEED. So in North America, more and more clients are asking for LEED Silver as a minimum. And oftentimes they'll say to us, we don't want to pay for LEED certification. Everybody know what LEED is? I'm just assuming that everybody does. Okay. Cool. So that's that's sustainability rating. The municipalities are saying design to LEED. I'm not going to pay to certify my building, but I want you to prove to me that it's certifiable. So we still have to do all the sustainability requirements and not actually apply for certification. This is just last thing. This is that Department of Energy. So this is the client who said to us, BIM me my telephone jacks and everything in between. And he basically is saying, when we BIMmed the project, we saved him millions with respect to finding interferences and ensuring there's change orders. It's a typical BIM thing, right? Fewer change orders on site, but it is so true. You design properly, there's nothing left to fix. Questions, comments?
I know it's obvious for buildings using BIM. You referenced many roads, but what's the largest scale that this software can be used to?
Well, the London Olympics was huge, right? So you think there was 9 main venues, from the stadium to the Olympic Village and all of that. There were 38 pedestrian and vehicular bridges, and I think 6 main canalways, and then all of the under infrastructure. So there were tube lines, an interaction with, I don't know if you guys are familiar with London, but there's the Crossrail system, so it's a brand new underground railway going across the city. And there's also a new piping being built underneath the river, underneath Thames. So all of those were interacting, so it's really on the citywide scale.
So in terms of, like on Monday, you had a person from Ellis Don come in, so he was also, they had their own BIM team.
Yep.
So if, let's say, Ellis Don and you guys combine, like there is a consultant, there is the builder. So who would take, one of you would take the BIM?
No, that's an interesting case, because I know it was Thomas Strum. He's a good guy. We've had discussions on this at the Canada BIM Council specifically on if I, the architect, or Strom Hill, are making a BIM model. If we're doing design bid, so you would go and bid on the project, I'm professionally liable for my information. So the association is, or the PEO or the Ontario Association of Architects are saying, turn over what you have to. If I give you the BIM model, it's an extra, but not a form of tender, right? And there's still ambiguity around whether I'm opening myself up for liability if I expose to you the work that I use to develop my form of tender, right?
Yeah.
But on design build, so if us and Ellis Don teamed on a design build, yeah, one of us, you know, if it was between Thomas and myself, we would both probably get together and say, he's the BIM rep for Ellis, I'm the BIM rep for CH, together we're the BIM leader for the entire project, and we coordinate our respective teams. And that would be the best situation. Thank you everybody for your attention.